let us study the cells in series. First of all, let us consider the three cells, cell 1, cell 2 and cell 3, and the EMF of all the cell be same. So if the EMF are same, then I will just write epsilon, that is EMF E and E. Now in many books it may be written as E1, E2 and E3, but I am not doing this way. Let us consider the EMF of the cells of equal EMF, right? So there is no harm. Similarly, these are the internal resistance R, small letter r and small letter r, and let this be the point A and let this be the point B. First, what we know is we have to say that the EMF of all the cells is same and the internal resistance is also same, and they are connected in series, that is one after another. Now let us find the net EMF in this cell. So the net EMF, okay, EMF, say this is E net, is equal to, of course this is in series, how much will be this one? This will be E plus E plus E, and this will be equal to 3 epsilon is the net EMF of this combination. Now if there are n number of cells, if there are n numbers of cells, okay, here we have how many numbers of cells? We have 3 numbers, 1, 2, 3. So we got 3E. Now if there is n number of cells, then E net will be how much? This E net for n numbers will be equal to, instead of 3 I have to write n E. So this is the net EMF of cells in series. Please remember that the EMF are all same. So E net, what we got, is equal to N E. So equation number 1. So let us find the internal resistance, net internal resistance of this system. So the net internal resistance is R, small letter r net, will be equal to how much? This will be equal to this R and R. So R plus R is equal to 3R, because all the internal resistance are also same. Similarly, for how many numbers? For n numbers of cells, what happened? The net internal resistance, small letter r, will be equal to n small letter r. Okay, because for 3 cells there are 3 internal resistance, 1, 2 and 3, and for the n number of cells there will be nr. Understood? So let this be equation number 2. So the equation number 2 says that R net is equal to nr, equation number 2. So these we got the E net and we got the R net. Now let us find the equation of current, which is very important, because, okay, I will tell at the last. Let us find. And one more thing, we know that the direction of current is from this, isn't it? Is from this. Okay, from B to A, because the current flows from negative to the positive. Okay, so now what we do is, let us connect this series of cells with an external resistance. For an example, let me connect it with an electric bulb. So this is my electric bulb connected with the 3 cells given in series. So this electric bulb is growing like this, and this is my external resistance. It is not the internal resistance. This is external resistance connected with this 3 cells, and it has got the external resistance, say EX, capital R EX. Now how much will be the net resistance in this situation? The resistance will be this plus and the resistance of this ball. Okay, in second case, the total, I will write the total resistance. Okay, after connecting the cells, after connecting the electric bulb is how much? After connecting the electric bulb is how much? The total resistance, let me write R of total TOT is equal to how much? The resistance of this and this plus this resistance, because all these are connected in series like this. So this will be R EXT plus the N into R. So this is equation number 3. The total resistance in this system has now changed into this one. So R of total is equal to R EXT plus NR. So this is equation number 3. Now let us find the equation of current. We know that this V is equal to IR. And what is V? It is potential difference. And what is E? Is EMF, which is also a potential difference. So I can write this E net is equal to I R total. Understood? This is E net. This is also potential difference. Both are potential difference. Current is I and R is R total. So then how much will be the current? So let us find the equation of current. It is very important. Equation of current. So then what do I get? I will have E net. I will divide it with R total, and this will be equal to I. Right? Okay. So then let us put the values, or this I is equal to how much? E net. What is the value of E net? E net is N epsilon. Understood? Now what is the value of R total? R total is R external plus N into R. So this is the current in this situation. Understood? So what we got is very important. This is very versatile equation. You have to remember this. Very versatile equation, that I is equal to N epsilon divided by R EXT plus N into R. So this is the equation of current in series. So this EXT, you can write EXT, no problem. Okay. Now see, let us consider the current. Let us see what will happen to the value of current. Either the current will increase in this combination or the current will decrease. Okay, this is now very important concept. So let us take the two cases. So first case, okay, this is my case 1. In case 1, I will just write that if R external is much greater than NR. Okay, what is NR? The total resistance of this cell. I mean the internal resistance of cell, and this is external resistance connected with this cell. So if external is much larger than this internal resistance, then what will happen to the current? Look at here. So then what I do, this will I will become equal to how much? There is N into E. Okay, and divided by R external is much greater, so I will just write R EXT. and plus NR is there, which can be neglected because this is 1 lakh and this is 1 rupees. So 1 rupees can be neglected. So this is the current in series. Okay, is it in series? Yes, this is in series. Okay, now for, okay, this is for series, isn't it? This is for series and epsilon is there. Now for one cell, then what will happen? For one cell, can you guess? Yes, for one cell, so I will write single cell. This will be I for single will be equal to, what is the value of n? This n will be this much by REXT. Understood or not understood? This n has become 1 and I got this one. Now tell me, compare this to equation, which is large? Tell me, which one is large? Here is n. If there are two cells, then this E, okay, E and this REXT is same in the both the cases. Here also E by REXT, E by REXT. It means these two are same. But there is n. If this is 2, then this will become more. If this is 3, then this will become more. It means that the current will increase. The current will increase in series when the external resistance is large. So the conclusion, we can say the current increases in series if external resistance EXT is much greater than internal resistance, that is NR. This is very important. Why? There is N. If it is become 2, then this will become, this is same, right? This and these are same. Then this and, if it is, say, this and these are same, if it is 10, then this will remain 10 for the both the cases. Then if there is 2 cells, then it will become 2 into 10, 20. If it is 3, then 3 into 10, 30. So in series, the current will increase if external resistance is much large. Now let us go to the external condition. So case 2. Case 2. Now when this is when REXT is much less than N into R. What does this mean? The internal resistance is now become very large as compared to the external resistance. So then again this I is equal to how much? This will be N E divided by, this will be N into R. Why? There is REXT plus NR. This time this NR is very large. This is 1 lakh and this is 1 rupees. Then we can neglect the 1 rupees which is here and we get only the NR. So this is equal to how much? This N and this will be cancelled and this will get E by R. And this is in series. Okay. Now for one cell, what will happen? For one cell, what will happen? Okay, then this I is equal to N, in place of N there will be 1, then 1 into E is E, no change, and divided by there is 1 into R is R, or this is single. Now if you see here, this and this, what we can say? This is also E by R, this is also E by R. It means that the current do not change when? Current do not change in where? Series, if R external is much less than internal resistance. So these are the two conditions which we must understand. Now there is one question. There is one very important question which I want to discuss over here. So if we have a motorcycle, okay, or a motor vehicle, and if anyway it is a vehicle which needs 12-volt battery to start. Okay, you have a 12-volt battery, this battery, and this is my negative, and this is my positive. With this battery, okay, with this battery we start the motor vehicle, and we lost it, and we lost the battery. We lost this battery, but we want to start this motor vehicle. Then we thought, let us have a 12 volt battery by combining all the cells. So there will be a cells. So let us take cells of 1.5 volt. Okay, and how many cells will make 12 volt? If I multiply this 1.5 into 8, it will give 12.0. Okay, so this volt, that means that I will get 12 volt by 8 cells of 1.5 volt. Now I connect the 8 cells in series like this. Okay, 1, 2, 3, 4, and from this theory we should get a how many volt? 12 volt, and it should start our motor vehicle because it needs what? 12 volt to start. But it will not start. It will not start. It will not start. Now think why it do not start. Because in this situation, the internal resistance of these cells will become very large. Understood? The internal resistance of the cells will become very large. Now, if the internal resistance, if this become very large, then what will happen? The current will decrease. Okay? The current will decrease because there will be a large number of internal resistance and the motorcycle will not be started. Thank you.